The question of how much protein you need to eat is, I think, fairly well settled by researchers in longevity like my colleague and friend, Dr. Valter Longo. And if you've noticed in my books, both the plant paradox and the longevity paradox, I use his formulas to calculate the amount of protein a normal, what's called a 70 kilogram man, 150 pound man, would usually need to eat. And it comes down, simply put, to probably about 20 to 30 grams of protein per day. Now, where do those figures come from? Well, one of the things that many nutritionists look at and forget is we actually recycle all of the protein that's in the lining of our gut wall. And we tend to shed most of our gut wall almost daily. At least every other day, all the cells lining our gut wall are kicked out and a new one replaces them. We don't waste those cells, so we actually eat those cells. Mucus, that, your runny nose, the mucus in the back of your throat, are mucopolysaccharides. They're sugar molecules with protein. And we actually digest that mucus. So we actually have a continuous source of protein within us that can make up for a lot of the protein we assume we need on an everyday basis. So that's where these figures come from. Now, I think one of the most striking studies that was done, published in 2009 in the Journal of the American Dietetic Association, there is a lot of controversy that as you get older, your protein needs may increase. And even Dr. Longo thinks that maybe after the age of 65 or 70, you should perhaps add more protein to your diet. My personal feeling about that, which was refuted by this study, is that even if you're elderly, you don't need to consume more protein. So in this study, they took volunteers of two age groups, young adults and senior citizens, and they had them eat a meal of either 30 grams of lean ground beef, 90% lean ground beef, or a meal of 90 grams of lean ground beef. And then they actually looked at muscle synthesis, building of muscle. In other words, incorporating that protein into muscle. The 30 grams of protein in that meat completely provided for muscle synthesis in both the young and the old. But the really startling thing was the 90 grams, either in the young or the old, did nothing more for protein synthesis. Now you have to ask, okay, what happened to the rest of that 60 grams of protein? Well, we don't waste energy, as I've talked about over and over again. We convert that protein, which we do not need to build muscle, we already met those needs with 30 grams, into sugar. It's called gluconeogenesis. Look it up. It's done in your liver. And that sugar is converted into fat. So the idea in human studies that you need more than 30 grams a day to completely synthesize muscle is refuted by, human studies, even in older adults. So, 30 grams actually is a lot of protein, and you can meet your total protein needs, in this study with 30 grams. And I think you need to take that to the gym, take that to the bank, and realize that we have completely overestimated the need for huge amounts of protein in muscle synthesis. We just don't need it. And these are human studies, not animal studies. One of the things I like to point out to anyone who will bother to listen is a bear in hibernation. And a mother bear goes into hibernation pregnant. She gestates her young, she suckles her young, She spends about 5 months in the den. She doesn't eat during those 5 months. She leaves the den with all of her protein, all of her muscle mass intact. And the reason for that is if she used her muscles as a source of energy, she couldn't hunt. Now, she leaves the den really skinny, and I have some wonderful photographs of grizzly bears really skinny up in Canada right after they came out of the den, but all their muscle is intact. So the point of all that is, if you eat, for instance, on a ketogenic diet, protein should be really only about 10% of your calories. About 80% of your calories should be fat. And you'll spare your muscles. You will not go after your muscles as a source of energy. We're not that dumb. Our design is pretty doggone smart. So we're over-proteinized in this country. I think one of the best examples of a human being who transformed from a high-fat diet to a high-protein diet is the late Dr. Robert Atkins. I have the pleasure of actually taking care of Dr. Atkins' head nurse. I have the pleasure of knowing Dr. Atkins' co-writer in all of his books. And Dr. Atkins was a cardiologist. And Dr. Atkins, as most of us know, was famous as being the high-fat doctor. And he got into so much trouble with the American Medical Association that he morphed into a high-protein doctor because, after all, protein's good for you. And you can actually see pictures of him, and again, I have eyewitness accounts of him, that he went from actually a fairly thin person when he was a high-fat doctor to progressively overweight. And when he died, he was obese. And I think he's probably the perfect example of us on a high-protein diet converting what protein excess that he was eating into sugar, which is then converted into fat. Now, you could mitigate this in a carnivore diet by, quite frankly, fasting. And so many of the people who describe a carnivore diet are actually combining a carnivore diet with fasting. But let me say this about the carnivore diet. One of the things that's missing from this discussion, and I think it's an incredibly important point, is there is this crazy sugar molecule called Neu5Gc, and in my book I say, who knew, that is present in beef and lamb and pork, which is the prevalent, things you eat on a carnivore diet. This sugar molecule does two really bad things. We don't have Neu5Gc. We have a very similar sugar molecule that lines our blood vessels, that lines our gut wall, called Neu5Ac. We share that with chicken and fish and shellfish. They have our sugar molecule. And there's a new study out recently that beef eaters had a much higher incidence of breast cancer than chicken eaters. And once again, the difference between those two sources of protein actually comes down to the fact that chicken has Neu5Ac and beef has Neu5Gc. And the evidence is overwhelming, sorry, carnivore diets, that Neu5Gc promotes inflammation, promotes an autoimmune attack on our blood vessels, and promotes cancer cell growth. And also, interestingly enough, there's really good info that perhaps our species became a separate species from great apes because of this mutation. The other great apes actually make Neu5Gc, like beef. And Neu5Gc damages your brain. It actually hurts neurons. And there's some really cool nerdy papers showing that one of the reasons we may have a bigger brain is because we mutated into a sugar molecule that doesn't bother neurons. So again, that's nerdy stuff. But the point of all this is there is no evidence of long-living people on a carnivore diet. Sorry, find one. I'll be happy to take it back. There is none. And the overwhelming evidence of the blue zones is the one thing they all share, and they all have different diets, is they have very, very little animal protein in their diets. Very little. It's the universal feature of these diets.